Okay. So I'm here with Maria Colgan, a dear friend and at RMOUG, and I just saw her give a great keynote, which was very well received. And last time I interviewed you, you were all excited about the optimizer, and now you're talking about the next big thing. I'm gone for a year, and Exadata was the hot topic, and now this is apparently even faster. The database in-memory column store. Okay, I'm not sure if I said that right, but why is it faster, and what's so great about it?
So it's great to see you back, by the way, and I'm delighted to share with you information about Oracle Database in-memory and the new in-memory column store. So it goes hand in hand with Exadata. It uses a lot of the same optimization techniques in order to speed up scanning and filtering operations. And those operations are typically seen in analytical queries. And the whole benefit here is to be able to improve the performance of analytical queries.
So one of the things that you mentioned was if I heard right, you said that it matters how the information in memory is stored, that the algorithm is close to what is actually expecting in the, what is it, SIMD register?
You're
okay,
right.
and you use the analogy of speed dating. So please explain that one to us.
All right, so there are a bunch of benefits we get from storing the data in memory in a columnar format in order to be able to speed up analytical queries. So the first, most obvious benefit is only access the columns that you need for the query. So we get data elimination by just accessing those columns. And then, of course, the format that those columns are stored in is important. So the first thing we do is we compress the data in each of those columns, giving us a good compression ratio and allowing us to be able to scan and filter that data in its compressed format. The speed dating aspect of it is something called SIMD vector processing, and what it does is gives us the ability to process multiple entries from each of the columns simultaneously within a single CPU instruction. So the reason why I made the analogy with speed dating is instead of going one entry at a time within the column, we are doing multiple entries just as you would with speed dating. Instead of going on one date for an evening, you can have a date with 20 potential suitors and see whether or not you find a match. So it's all about set processing and speeding up the evaluation of the data in the columnar format.
Excellent. So I can find out faster that that's not really the one I want, and you get closer to the end point.
Exactly, yes.
Great. So with the columnar data, that is not the hybrid columnar data that we know from Exadata. How is that different?
That's a very good point. So although we are pivoting the data from a row format to create the columns and then compressing it, in memory it is very similar to how we do it with HCC, but they are not the same, and the difference in the format comes in actually making sure that the in-memory columnar format lines up nicely with those SIMD registers. So that's where the key difference is. The formats that we're using are slightly different, and the reason we changed it for in-memory was in order to be able to take advantage of the SIMD vector processing.
So it's really about speeding up the performance, not so much on the logging. You said there was no logging involved. How does that fit in?
That's a very good point. There is no additional redo or undo generated with the in-memory column store. All of the data changing operations are processed through the buffer cache or the row format just as they are today. And we are keeping the column store transactionally consistent and in sync with that row store simultaneously, but there's no additional logging for that. So if I were to do the same thing and create an index on a table trying to help speed up the performance, we would have to make changes to that index and then log those changes in both the undo and the redo, and that's no longer necessary with the column store. Because it's purely in memory, there is no additional redo or undo required.
So now, me as the application developer, not that I am, but if I was, would I have to know about how to do that? What's the onus on the application developer? So
this is where the magic is. There is no onus on the application developer. As long as your application connects to the Oracle database and issues SQL, you can take advantage of the in-memory column store. The Oracle Optimizer is fully aware of what objects are in the column store, what storage indexes have been created on them, what kind of compression we've achieved on those objects. So when your query comes in, we look at it to see whether or not it would benefit from accessing the data in that columnar format. So in other words, is it an analytical style query? If it is, we'll automatically direct it to the column store for you. You don't need to be aware of it within your application at all. So as long as you connect to the Oracle database and issue SQL, you're good to go.
Excellent. And version of the database that it's supported in?
Very good point. So this is brand new technology in Oracle Database 12c, and it comes with the first patch set to that 12c database. So it's Oracle 12.102 that was released in July of last year, so July 2014.
Excellent. Maria, as always, thank you very much. It's always educational talking to you, and I appreciate it.
No worries, the pleasure's mine.